So where we are in section 5.2. This section happens to be probably the most difficult section to deliver in a clear and coherent manner. I usually follow this lecture on 5.2 with a lecture called Factoring Polynomials 2 right after this. But we have this added challenge of having this being in an online delivery. So what I've done is combine these two lectures together into 3 videos. So in this first video on section 5.2, we're going to simply focus on objective 1, factor trinomials when the coefficient of the second degree term is 1. So again, objective 1, factoring trinomials when the coefficient of the second degree term is 1. Basically what that means is the leading coefficient is 1. So step 1, so what we're looking at look at the top here. Here is the standard form of a quadratic, and this polynomial is a quadratic. So notice we've got variables in front of the x is b, and then we have the last term is c. So the idea is to find pairs whose product is c, the third term of the polynomial, or trinomial, sorry. And we want to find, as we find the pairs of c, we want to look for something particular about them, and that is that they also sum up to b, the coefficient of the middle term. And if there are no such integers, the polynomials cannot be factored. A polynomial that cannot be factored is called a prime polynomial. And these are examples of prime polynomials. If you were to look at each one of these, looking at the factors of c, there's no factors of c that sum up to that middle term. We'll get to more into how we deal with factors of c that sum up to b here in just a moment. So here we have a trinomial. Notice that the leading coefficient is 1 here. So the idea here is step 1, find pairs of numbers whose product is 20, which we're indicating here, the c term, and we want to find some pairs of numbers that have a product of 20 that sum up to 9. So bear with this process here as we work through this process here. Just bear with it here. So 20 and 1 are factors of 20, but they sum up to 21, not 9. And negative 20 and negative 1 do get us to a product of positive 20, but they sum up to negative 21, not 9. 10 and 2 also get us to a product of 20, but they sum up to 12, not 9. Negative 10 and negative 2 also get us to a product of positive 20, but they sum up to negative 12. Then we have positive 5 and positive 4. They do get us a product of 20, and they do sum up to 9. So we found our pairs of numbers who we want to use to factor this trinomial. And then it just includes negative 5 and negative 4. They give us a negative 9, but we want a positive 9. So we found it, 5 and 4. Keep those numbers in mind. So as it says, the coefficient of the middle term is 9, so the required numbers are 5 and 4. So here's the factored form, a plus 5, a plus 4. And we can always, whenever we factor, we should always check by FOIL. And here we are, that it comes out to be a squared plus 9a plus 20, which was the original trinomial. But I do want to pay particular attention to the inner and outers. 4a and 5a whenever we do the inner and outer, right? Notice that they're the ones that are summing up to 9. Because a lot of times what we're doing here is unfoiling. So just keep that in mind. The inner and outer sum up to that middle term. And it checks. So here we're going to factor another trinomial that has a leading coefficient of 1. So what we're looking for is integers with a product of 10 that sum up to -7. So what we would do, we would look for these pairs. 10 and 1 gets us to a product of 10, but they sum up to 11. -10, -1 get us to a product of +10, but they sum up to -11, not -7. Remember, we're looking for -7. 5 and 2 get us to 10. They sum up to +7. We're looking for -7. And here we are, -5, -2 get us to +10, and they sum up to -7. So we have found the pairs of numbers that will help us to factor this trinomial. So here it is in factored form. Notice we have b minus 5, b minus 2, because our numbers were -5 and -2. And we should always check by FOIL. Notice again, the inner and outer are what are summing up to that middle term, -7. And that checks. Here we have another one. So we're looking for integers with a product of -5 and sum up to -3. The only factors of 5 are 1 and 5, and there's no combination of negative and positives that would sum up to 3. So we call this trinomial prime because it will not factor. So we're still looking at, notice this one doesn't have a leading coefficient of 1, but it does have a common factor, a greatest common factor that we can take out. We can take out a 3a. So what we do is take out a 3a. Now we have a factored form, but we have this trinomial here. And now let's see if we can factor it further. So remember, we're looking for numbers that will give us a product of -5 and sum up to +4. So we could list these factors, but the textbook goes ahead and points out that we're looking for a product of -5 who sum up to 4, and necessary integers are -1 and 5, right? Because -1 plus 5 gives us +4. So we move it into the factored form here. Notice here we have a minus 1 and a plus 5. And we should always remember to check this by FOIL. And just so we are aware, there are some sign rules for factoring trinomials. This will just help you to understand a little bit more about how these things work. So if you happen to have two positives in the trinomial, you will have two positives in the factored binomials. If you have a negative in front of the b term of the trinomial and a positive in front of the c term, you will have two negatives in the factored binomials. If you have a positive in front of the b term and a negative in front of the c, you have a negative and a positive in the factored binomials. And finally, if you have a negative in front of the b and a negative in front of the c, you have a negative and a positive in the factored binomials. So let's look at a couple examples out of the homework. First off, it says complete the factoring of x squared plus 11x plus 24. notice it gives you the first factor. But let's just consider that we're not given that. So here's the idea of what you do when you factor these with the leading coefficient of 1. All right. So first off, we notice we have a positive in front of the B and a positive in front of the C. So that implies that both of the signs in our factored form are going to be positive. So first off, let's look at the factors of the last term, which is 24. And I usually indicate this by putting an L, and then I list my factors here. Why I use that L will be a little bit more clear as we start working with trinomials that don't have a leading coefficient of 1. But right now we're just looking at the factors of the last. So we got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So we've listed the factors. So now the question is, which ones of those, through addition, because we have two positives in the trinomial, so that means we're going to have two positives in the factored binomials, will add up to 11. Okay, obviously 3 and 8 will work. So now we pretty much factored this thing. So because 3 plus 8 gives us 11, so here we are. Here's the factored form, x plus 3 times x plus 8. And then we should check this by foiling it. Now let's look at the next one here, complete the factoring. Notice now we have a negative in front of the B and a positive in front of the C. Remember, that is the case where there's going to be two negatives in the factored binomials that we create when we factor this. So once again, let's list the factors of the last term, which is 15, which is 1 and 15, 3 and 5. Which one of those through two negative signs will give us negative 8? Obviously here, 3 and 5 will get us there because negative 3 minus 5 is negative 8. So there we are. We have the factored form of the trinomial.